So a very warm welcome to the Drupa Cube. Thank you for joining us. Get ready to be ink-spired. Now, the Drupa Cube is the primary conference venue here at Drupa, and we aim to bring you actionable business insights into a whole variety of topics, from business leadership to global trends to future of print and packaging technologies and sustainability. And today, the whole day really has been dedicated to sustainability in the circular economy, looking at it from all sorts of different aspects. So we started with a keynote on climate change, then we looked at paper as a substrate and how that works in the circular economy. We've just looked at printing technologies, inkjet printing, and how that can lower the environmental impact. And fantastically, we're going to end today with inks. So today's final session has been curated by the VDL, which is the German Association for Inks and Coatings. How inks and coatings can be recycled as part of the circular economy. It's my pleasure to introduce our two speakers. Our first speaker is we're going gentleman first today. He has 30 years of experience in the print and packaging industry. He's an expert in solvent-based flexible packaging inks for gravure and flexo printing, but he also has experience in water-based inks, and we'll be looking at all sorts of different inks. At Sun Chemical, he leads teams that develop solutions for the packaging industry in EMEA, where he is Technical Application Director, Packaging Solutions. Please welcome Ewald Rempel. And joining Ewald, she is Head of Global Sustainability and Circular Economy at Siegwerk Druckfarben. She is dedicated to sustainability and also driving transformation in packaging for her company, but also for the industry. Interestingly, you developed a circular economy roadmap for Germany as part of the Circular Economy Initiative Germany. So on a very broad scale, she's driving sustainability initiatives. Please put your hands together to welcome Alina Marm. The stage is yours. Thank you.
Yeah, good afternoon. I'm glad that you decided to come here on a Saturday afternoon, despite of the long weekend and, not so very nice weather. We want to talk about circular economy, but we also want to talk about packaging, recycling of packaging. We want to talk about inks and how inks contribute in the question how to best recycle packaging. We want to talk about the contribution of ink suppliers when it comes to recyclability of packaging. So when we talk about packaging, when you look at your garbage at home, maybe you have an idea that what you put into this bags, that ideally it should be recycled and should look like that. So you get nice, transparent, homogeneous flakes, and you can directly reuse it for new plastic packaging, plastic films, flexible packaging. Unfortunately, that's so far just a wish, because what we get today is something like that. We get recyclates, we get post-consumer waste, which is mixed together with a lot of components. We have inks, we have packaging, we have paper, we have plastic, and we have a lot of residues of food. We have adhesives, we have aluminum, plastics. All that does not really help us to get a clean, transparent, nice post-consumer recyclate. What we get is something which is dirty, which is impaired. So we have residual odor, smells, we have gel particles, we have spots on the recyclates, we have different colors, we have, not even the same optical uniformity, and we have hazy pellets in the end when they are recycled. All this recycling, we have made it very simple here. We get first the post-consumer waste. It is sorted it is washed, then it is heated up, melted down, and extruded at more than 200 degrees Celsius. So circular economy and packaging and recycling is a fast-moving topic. Today, recycling techniques and packaging materials are not really fit for what we as ink suppliers, what you as consumers envision maybe for as recycling goals, and what also the European, national, global institution have in mind when they talk about recycling, when they talk about recyclable packaging. So this means, how do we get to a better recycling process? How do we get to better recyclates? First of all, we have to understand how recycling is being done today. What are the designs for recycling? Can we improve those designs? And how can we as ink suppliers, how can you as consumers influence that? How can we improve packaging designs? Another question, or the second question we have to ask ourselves is, how can we participate as ink suppliers and get more innovative inks? How can we maybe talk to our packaging partners, the substrate suppliers, the machine suppliers, the adhesive suppliers? How can we together participate in creating innovative inks, innovative material parts which improve the recyclability of today's recyclates? And how can we, together with the institutions, with the other corporations and associations, work together in innovating recycling techniques? How can we improve recyclate quality? You see on this, you see it here in the corner, the percentage of the rate of recycling today in the European Union, as we had in 2016, we were talking about 42% of all packaging recycled. We had even a small drop by 5 years later, and we estimate a recycling rate of 50% next year and probably 55% by 2030. Although we want, or the target is, that by 2030 all plastic packaging should be recyclable. So what we, Alina and myself, want to talk about today is 5 parts of this presentation. We want to start, or I will start with life cycle assessments and the perspectives of inks in the packaging. We are going to move then to talk about packaging structures, about different packaging structures as they are today in the market, and trends, how packaging structures will be looking in the future, all the different components which play an important role in packaging. We also want to talk about ink binders, ink itself, nitrocellulose. I don't know how many of you have ever heard of nitrocellulose. I hope some of you. And we want to shortly touch on that and talk about the importance of nitrocellulose in packaging inks today and how it might look like in the future. And then I will hand over to Alina when we come to the real interesting stuff and talk about de-inking for high quality recyclates and general driving forces for a circular economy. So let's start with an LCA, a life cycle assessment. A life cycle assessment is a systematic method to evaluate environmental impacts of a product, the process of producing packaging, in our case, activity throughout its entire life cycle, and the impact on the carbon footprint. LCA considers various environmental aspects, such as resource depletion. LCA talks about energy consumption, greenhouse gas emissions, and other pollutants. The LCA helps identify areas where improvements can be made to minimize environmental harm and optimize sustainability. But very often, this is still lacking. So you see here on the picture on the right side, a typical life cycle with different streams. So that you see, starting on the right, on the top, this is where the raw material, the natural resources are used, are being brought in, where we extract raw materials, where inks are produced, where substrates are produced, where plastic containers are produced, where they're printed, where they're packed, where they're used, or first of all transported to the retailers and to supermarkets, then are sold to consumers, and finally end up on a disposal unless they are recycled or reused. So life cycle assessment is the total cycle on the left side from your perspective. So life cycle assessment starts with the raw material manufacturing. So this means all the pigments in an ink, all the resins, the additives, the solvents, all that needs to be manufactured, harvested, synthesized, so needs to be produced. And then inks are produced, and after the inks, there's a printing process, there's a packaging process, there's a converting process, and then the packaging is being transported to the brand owners. It's being filled with food or other packaging goods. Then it's being sold in supermarkets. It's in the product usage phase until it reaches its end of life or is being recycled and reused. So this means an LCA must cover the full life cycle of a product. But printing inks, and especially printing ink producers, can only impact this life cycle in one part. That's why we as ink producers would rather talk about specific product assessments. We would like to talk about the two dots which you see here. Can you see that? No. So talk about the raw material manufacturing and the product manufacturing, where we as ink producers have a direct impact. Means we focus on all the raw materials we use for our inks. We help our customers to get the inks then printed and help them also to convert the packaging. But after that, the ink producer is usually out of the scope, and then it's at the converter side, it's at the brand owners. So this means we as ink producers don't have a real picture and a real impact what happens to our inks later on in the stream. So what we are talking about and what we can influence is what we call the cradle-to-gate approach. And here we have another display of the cradle-to-gate approach. Means you can see in the gray area where we participate as ink suppliers. We produce, some of us produce our own raw materials, our own pigments. We convert pigments into liquid inks. And then once we have the inks produced, once we have them ready and checked, we send those inks to our customers. And we help our customers to print the inks then in their different printing processes. For me, it's mainly, I have most experience in printing gravure or flexo printing for flexible packaging. So we can enable our customers to get a clearer picture how much our ink is really impacting their carbon footprint, how much we are participating and contributing in their circular economy. And that's the part where we are active. Or to look at it from a different perspective, we as ink suppliers are pretty much at the beginning of the value stream. You can see here on the left side, this is where all the raw materials are produced for us as ink suppliers, but also for the substrate suppliers, for the adhesive suppliers. All of us, we start on the left side with the production of the different components in our inks or other products. And then we produce the ink, and then we send it to our customers. And that's where our participation more or less ends. But the value stream continues. I mean, our customer print the ink, they convert packages, they laminate it, they add functionality, barriers, and other stuff into the packaging, and then it's being filled at the brand owners. It's sold into the market. It's used at the end user, and finally it comes to an end of its life, or it's recycled and reused. This means that we as ink supplier only contribute more or less with 2% with the finished product carbon footprint. So we try to influence that, we try to help, we try to recommend the right inks and the right approaches, but our influence is pretty much limited. Now I would like to talk a little bit more about what our customers are doing, a little bit more about packaging, the kind of different packaging structures you find today when you go into a supermarket. First question is, why do people use flexible packaging? In the past, we had most of our food and all this stuff we wanted to use either in containers or in bags or in glass jars. But nowadays, when you go to a supermarket, you will find very little packaging in glass or metal containers. Most of the packagings you find on a shelf is flexible packaging. The question is, why is that? Well, first of all, it's cheaper to, at least at the moment, to use a flexible packaging than to use an alu container, a metal container, a glass jar. And second of all, it has less weight and less volume to use flexible packaging instead of rigid containers. But if we use flexible packaging, we certainly need to create similar functionality, similar properties of the packaging when we use flexible packaging compared to rigid packaging. This means we need to have the right barriers in the flexible packaging. We need to have light barrier, we need to have moisture barrier. The packaging should have a certain oxygen barrier. It should not be infested too much with microbes. It should not change its taste and its smell. And we want to avoid that the liquids, if we have a liquid packaging, evaporates too fast. And we want to physically contain what is in the packaging. So this means today, or until recently, usually flexible packaging is a pretty complicated thing. We have usually multi-layer packaging, different substrates, different structures, depending on what kind of material we have packed. If we have food packaging, if we have hygienic packaging, if we have liquid, dry packaging, all that needs to be protected, all that needs to be advertised. I mean, packaging is not only preserving something, preserving food. Packaging is also marketing. Packaging is advertising a message to the consumer. So this means in order to be able to do all that, you need, at the moment, a pretty complex packaging with different layers, barriers, layers of protection, layers of messages. And what we want to do for the future, what the trend is for the last few years, is to really reduce material complexity, to move away from multi-material packaging to monomaterial packaging, to move from complex structures which are not recyclable to flexible packaging which is recyclable. So the trend is going away from multi-layer packaging to either monomaterials or to coated substrates which are thinner, which are less complex. So when we look at the different substrates, different possibilities nowadays converters or brand owners have to pack their goods, you see 5 different categories here on the slide. On the left side, we talk about monomaterials. Monomaterial means it's one kind of substrate. So we have the polyolefins, which are polyethylene or polypropylene. We have polyesters, we have polyamide films, and then we have films which are coated. Especially the polyolefins are very often coated with different coatings in order to enhance the functionality or to give us certain barrier or sealing properties. So this means we have organic coatings like an acrylic coating. We have EVOH as a barrier coating on polyolefin films. We have PVDC as an aromatic barrier for packaging. And then if we want to increase the level of barrier, we have ceramic coatings which can be applied on polyester, on polyamides, on polyolefins as well, like silicon oxide or aluminum oxide as coating. And if we even want to get further than that, we have metallization layers, or even more than that would be a real aluminum layer in between. And as I said before, the traditional multi-layer packaging, which can consist of up to 5-6 different layers in a flexible packaging. Why do we have different substrates? Why do we not just use one plastic film for every packaging we see in the supermarket? Why do we have PE, OPP, polyamide, polyester, ceramically coated, organic coated substrates? Well, that's because mainly of its functionality, but especially because of its barrier properties. So you see on this graphic from left to right and from down up the different transmission rates depending on the kind of substrate we are using in a packaging. So this means the ideal barrier where nothing can get through is on the left down edge, where we have steel or aluminum or glass jars. There nothing can get through. But if we then move to the right, or if we move up, you can see that the barrier functions decrease. So for example, we have a pretty good barrier with polyethylene for moisture, but it's comparably bad when it comes to gas or oxygen barrier. And so I will not go through every single substrate, but you can see the further you move to the left and to the down, the better the barrier functions are. And this knowledge of barrier function of substrates is certainly also known at converters. They use this for their packaging. So I have brought, or Alina and myself, we have brought several examples where you can see today packaging as it is used in the market. For example, the cheese. Alina, can you just, This is a typical German cheese packaging, and it contains, it is printed on a polyamide-oriented polyamide film, and it's laminated against polyethylene to have a sealable layer, and then you have the cheese inside, and then it's sealed together with a container which contains the cheese. So this means we use this polyamide because of its very good oxygen barrier, but we don't need so much vapor barrier. We don't need the water barrier for a cheese packaging because its life cycle is pretty short, and its moisture is already inside, so moisture will not spoil the nature of the cheese. And we have other packagings. I brought also, for example, a ham packaging where we have ham packed in a PVDC-coated polyester, or the PVDC-coated polyester is printed, is then laminated against PE and sealed against a polypropylene container. Here, the brand owner decides to use PVDC-coated polyester in order to have a good aroma barrier. He does not want oxygen to come into the package and to affect the quality and the taste of the ham. I also brought some cat food. I don't have any cat. I don't know how many of you have cats. But I've been told that they are pretty picky about the foods they have to eat. So this means we have to protect the pet food. We have to make sure that it does not change the taste, the smell. And therefore, this is the triplex structure. You have polyester printed, laminated against aluminum, laminated against polyethylene, and then sealed together into a doi pack pouch. And I also brought some rice. Uncle Ben's. This is also a typical example of a doi pack, of a pouch, a triplex packaging. No, this is a duplex packaging, because here the brand owner decided to replace the aluminum part with a ceramic coating. This means we have polyester, which is coated with an aluminum oxide layer, and we get similar barrier properties than if we had a triplex structure, if we had aluminum between. The good thing is the consumer can look inside the packaging. He has a window and can decide if he likes what he sees there or not. Okay. So, coming back to monomaterials, the trend nowadays in our markets is to move from, as I said, from multi-material to monomaterial packages. And there we have to differentiate if we talk about a single layer packaging, means, for example, a polyethylene bag, which is printed on the surface, maybe contains an overprint varnish, and it's sold like that in the supermarket. That makes it pretty easy to recycle, because you can just de-ink the packaging easily. The ink is on the outside, and you don't need to delaminate any substrates. And you still have, through the polyethylene, a pretty good moisture barrier. The thicker the PE, the more the moisture barrier, obviously. And it's a very flexible pouch, which you can use in your freezer or wherever you need it. The disadvantage of this kind of package is that the gas barrier, as I said before, the oxygen barrier, is not very good. And depending on what kind of monomaterial I'm using, it is the worst with polyethylene, and it gets better if I move to polyester or even up to polyamide. But then we have also monomaterial packaging structures where we have the same material, polyethylene, laminated against another polyethylene. It's still a monomaterial packaging. We have some ink and adhesive in between. But if we want to recycle it cleanly, we have to open it, we have to delaminate, and then de-ink the ink from the packaging. Another kind of packaging, another kind of film I mentioned before is what I called coated polyolefins. This means we talk about polyethylene as substrate, and we talk about polypropylene or other polyolefins like that. What are the advantages of using coated polyolefins as monomaterial packaging or as multi-material packaging? Coated polyolefins themselves have a very high moisture barrier, much better than the polyolefins themselves. They have a far increased oxygen barrier and a much increased aroma barrier. And that's one advantage to the ceramic coatings we talk later on. They are pretty flexible, so they do not easily crack when you have the packaging in your hand. The disadvantage when using coated polyolefin films is that they tend to yellow in the recycling process. This means with this heat influence of the melting and the heat in the granulating process, this tends to create yellowing of the packaging when we have an organic coating. And also, and that's even worse, we have the issue that, or the potential to create carcinogenic dioxins when a packaging is printed or is coated with PVDC. And that is an issue which the consumer doesn't want and the brand owner doesn't want. So the next group would be ceramic coatings. Ceramic coatings we find on polyester with BOPP, B-oriented polypropylene, and also polyamides. Advantage of a ceramic coating is that it generally has a quite good barrier property in general. It is fully compatible with the recycling stream. We don't have any aluminum which would disturb the recycling. It is not detected in any metal detectors in the recycling process. And it's also suitable for microwave. As consumer, you would rather have a ceramic coating than a triplex structure, because you can put this packaging into your microwave. The disadvantage of using ceramic coatings in packaging is, as I mentioned before, that this ceramic coating is not really crack resistant. It's not flexible enough. It will easily crack when we have mechanical stress, and you can then lose the barrier properties you want to have. Aluminium oxide as ceramic coating itself is quite difficult to be overprinted, and silicium oxide, which is also used in different kind of ceramic coatings, is pretty difficult to laminate. Another aspect, an important aspect, is the cost of ceramic coatings on polyolefin films, which increases the price quite significantly. Another way of increasing barrier, as I mentioned before, is metallization. Usually you will find metallized polyester films, you will find metallized BOPP films. Advantage of metallizing a film is, first of all, you get quite good all-round barrier properties. Now, especially when it comes to light barrier and aroma barrier, metallization is still used very much in the market. Still, if you go to a chips pouch, still most of chips pouches you find on the market have a metallization somewhere inside. Disadvantage of metallized films is they are not separable during the recycling process, and they cause discoloration of the recyclate. And they are detected in the recycling stream through the metal detectors. And another part, I mean, you would not put the chips pouch in the microwave, but other packages, they cannot be used with metallization into the microwave. Multi-layers is what I described before. So depending on what kind of layers you have good barrier properties. They're really tailor-designed for the needs of the packaged good and for the design and the marketing ideas of the brand owner. Problem and disadvantage of a multi-layer packaging is that they are not fully recyclable in many cases, that they would need delamination if we want to de-ink or take out the ink or create monomaterials. So in many cases, you would need, first of all, a delamination primer in order to be able to do so. So much about packaging structures. Now, in the next step, I would like to talk about binders, about resins which are used today in inks for flexible packaging, mainly in solvent-based inks for flexible packaging. And one of them, which has been discussed a lot recently, which is being questioned by recycling institutes, by associations, by converters, is nitrocellulose. For the chemists in this group, you can see on the right side the chemical formula of nitrocellulose. Nitrocellulose has been in the market for many years. At least, if I remember right, at least 50, 60 years, nitrocellulose has been the main binder for printing inks for solvent-based flexible packaging. So to remove nitrocellulose from inks is quite the challenge for us as ink suppliers, and it's also a challenge for all our partners. The printers need to get from us an ink which has a good printability, which has the necessary intensity, color strength, which gives the right compatibility with all the other components in an ink, which gives the same performance basically of inks as they are used in gravure and flexoprinting today. So just for you who have never read or heard a lot about ink, when we talk about solvent-based flexible packaging inks, of four main resins, four main binders as they are used nowadays still in flexible packaging. On the left side, we talk about what I've mentioned before, nitrocellulose inks, and in many cases the nitrocellulose is not the only resin inside of the ink, but it's a combination with nitrocellulose and polyurethanes or other co-resins. And we have decided to give you an idea why there are so many different binders. What is their function? Why do we use nitrocellulose for some ink? Why do we use PVB for other inks? Why do we use PVC, although we use every day less PVC? And why is there polyurethane as a binder in inks? So NC is general a binder which is pretty compatible with everything. It's a hard resin. It can be used very nicely to print in gravure printing. It has a very good performance in flexo printing. The nitrocellulose binder itself is not so good when it comes to pasteurization, and it's absolutely not suitable for sterilization, for retort packages. But it can be printed in different combinations on all kind of different substrates. You can print with NC, PU inks on polyester, on OPP, on PE, on polyamide, on polystyrene, on all kind of flexible packaging which you find in the market. You could theoretically use nitrocellulose-based inks in combination with other stuff. You can use it in surface printing. It's very hard and it's very resistant. You can also use it for lamination if you combine it with the right polyurethanes or other additives. It is certainly not as good as other resins when it comes to high bond strength, high performance inks, but for medium, for big parts of the packages of a converter of our brand owners, it's more than enough. So when we come to PVB, PVB is also a resin, is a binder system which has been in use also more than 40, 50 years, I believe, all across the world. And it's still used in certain applications, especially in gravure printing, but also in some parts in flexo printing. It has a better adhesion than nitrocellulose on different substrates, especially on polyolefins. It enables to have better bond strength values, but it has not that good mechanical properties, so it's not so good for surface printing. But when it comes to bond strength values, when it comes to lamination properties in general, a PVB ink is generally better suitable for a lamination pouch than NC or NCPU. PVC is something which the market doesn't want any longer. For several years, several of the large brand owners, for example Nestle, have stated that they don't want PVC in their packaging, and I think they banned it already 2-3 years ago. But there are still certain brand owners who allow it, and there are mechanically very good advantages of using PVC in heat seal varnishes, in inks, especially when it comes to gravure printing. Unfortunately, PVC is not suitable as a flexo binder or as a flexo ink, but for gravure, the printing performance and the whole printing result is very, very good with PVC. The pasteurization, sterilization properties, the bond strength values are very, very good when used PVC-based inks. Unfortunately, the resin itself is so soft and is so tacky that you cannot use it for surface printing, at least not without an overprint varnish. So it is not suitable for all kinds of PE pouches, paper packaging, everything where the ink is laying on the outside. So the most versatile resin, and that's why I believe it's one of the most important future binders or binders for the future of flexible packaging is polyurethanes. First of all, there's a huge and broad range of different polyurethanes, and many of the large ink producers synthesize their own polyurethanes, so they are able to really adjust this kind of binder to their customers' needs. And polyurethanes as binder enable inks which are suitable for both gravure printing, flexo printing. They're suitable for pasteurization, for retort application. They are universal binders for all kinds of substrates which you find on flexible packaging. The only disadvantage, or the only part where it gets a little bit complicated, it's when printing in surface printing without the use of an overprint varnish. There the ink would be too tacky and too soft. So this is the only case where a polyurethane-based, a full PU ink would need protection in order to be suitable. So to look at the whole picture, binders for nitrocellulose or NC-based inks today are by far the largest part. NC-based ink is by far the largest binder system in the world, in every region, mainly for flexo printing, but also 75% of gravure inks printed on polyolefins are still based on nitrocellulose. And now we come to the problem with nitrocellulose. Nitrocellulose has an issue when it comes to recycling, has an issue when it comes to the performance or the outputs of recyclates we get if we have nitrocellulose-based inks in packaging. Means the high temperature in the nitrocellulose or in the recycling process leads to decomposition of the nitrocellulose itself, creates gas, creates NOx, creates unpleasant odors, and really taints the recyclates, makes them look dirty, and therefore nitrocellulose as main binder in inks is something which is a problem if we want to have recyclable packaging. Yeah, here I have it on this slide. Today 90% of nitrocellulose inks in flexo, of all inks in flexo printing, are based on nitrocellulose, and about 75% for gravure. In gravure we have more PVC, PVB and PU inks, but still the majority is nitrocellulose. And there are a lot of different regulations, a lot of different discussions with different associations. We have in Germany here the minimum standards of the ZSVR. Is that the right ZSVR? ZSVR. So this means there is a minimum standard in Germany which indicates or which regulates a large format of PE laminates in order to be within the minimum standard. So this means anything which is larger than a DIN A4 sheet is not suitable or is not within the minimum standard. We also have different packaging and packaging waste regulations in the EU, which see nitrocellulose as a real problem for recyclability. And by 2030, all packaging, as I said before, must be recyclable, so all non-recyclable packaging will be banned. Then we have the CEN Institute, which wants to regulate design for recyclates and the criteria to be able to design recyclable packaging. And this is anticipated to be in a written form available by 2027. And then we have huge associations of printing, of converters, of packaging manufacturers, ink suppliers, and so on, which are in big associations like Recyclas or CFlex. And they also are working on design for recycling guidelines and amendments of the existing recycling guidelines, which I think a part of it has already happened end of last year, beginning of this year, but more is expected to come. So as a conclusion, if we talk about nitrocellulose, we see that we will get some kind of design for recycling criteria for inks from Recyclas, from CFlex, from CEN, and others. And we see the necessity as ink supplier to formulate inks which are at least significantly reduced in nitrocellulose, but in many cases, and ideally, free of nitrocellulose. The good news is we have already other binders, as I have presented before. We have inks based on PVB, on PU, on PVC, even though, as I said, PVC is also disappearing from the market. And we have products, we have inks, we have products to offer which enable a deinking, which enable also, instead of a cold washing process, a simple only de-inking process. And that's the part where I hand over to Alina.
Right.
Thank you.
Thank you very much. So we talked a lot about different binder system for inks. And to some extent, it seems that PU is a solution. However, I want to be a little bit more of a party pooper and say, actually, it's not really the full solution. If we want to get to a place where we actually use the material that has been mechanically recycled and put it back into packaging that is accepted by the consumer, that is safe, but that's also machinable and printable and all the other technical requirements it has to fulfill. The reason for this is, I think, quite nicely summarized here in the table. So while PU inks do improve the situation to some extent, they still create a recyclate, so what comes out after the recycling process, that has this typical discoloration that we know. So the gray, the brown, the smell is a little bit better, but if you would smell it, you would still smell it's a recycled plastic, and it's still not safe for food use, which, of course, if we think about circular value chains, is sort of the holy grail that we want to get to. So one solution would, of course, be not to print on packaging, because then you don't have any of those discussions that we just had. I'm going to take my hat off working for an ink supplier for a second. In theory, this would be a great solution. But I have yet to meet a brand that will say, oh yeah, sure, I'll give up that marketing space, that opportunity of differentiation. Yet have I met a consumer who willingly gives up certain identifications with a brand that they buy, yet alone sort of essential information that is printed on packaging. Just think about if you have severe food allergies, or you're trying to watch what you eat and you want to know how many calories that cookies has. So I think we have to take a step back and think about, well, if the change in the binder systems is not the full answer, if not printing is not the answer, what could it be? And actually there is one. And Ewald mentioned it a few times. It's deinking. So in very basic terms, it's washing off the ink as part of the recycling process and before it enters the pelletization process. And I'll explain that. I'll just give it into the, I'll explain it a bit more in detail, but I already want to give you something that you can, where it becomes a bit more visible. So what you see here is a non-branded pouch, but one that you would find typically in the market, maybe also one where rice, for example, could be packaged. I'll give it out in a second. And this is a full PE structure, so it's fully recyclable. But what would happen if we would give this into the mechanical recycling process, despite it being a full PE, you would still get pellets that have a certain discoloration. I'll just hand you this. The reason being, I shred it as part of the recycling process, but nonetheless, and you see it, and you can open the bags, by the way, you see I still have the color, of course, on the flakes. And those flakes is what would enter the pelletization. You have an important job to sort of pass it on. What we do in the deinking step, or what the recycler does in the deinking step, I should say, they use a hot washing process. Hot washing is something that has been done for many, many years in the PET recycling process. This is one of the reasons why bottle-to-bottle recycling works, because we hot wash the bottle. We make it safe, and of course, then allow for the use again in bottles. And hot washing, together with sort of washing chemistry, can also be a solution for flexibles. Because what happens, and sorry I have to interrupt you again, you have your important role again. You get clean flakes. And it's probably not difficult to understand that if you give clean flakes, de-inked flakes, into the extruder, you will also receive significantly cleaner and better pellets that you can then use for the different applications. So this is ultimately, if we think about the future of inks on packaging, and we do not believe there will be inks without packaging without inks, something I would urge us as an industry to really, really push forward. It's simple and it's feasible. Now you might think, what has to happen to the package to make that possible, in addition to the recycling process, in addition to the hot washing? Good news is, often, nothing. So many of the existing ink systems today, they are actually de-inkable in the conditions that we usually find in a de-inking process, especially those surface prints, 1K system, that we want on packaging anyways, because we don't necessarily want those laminates. Even if we don't have this yet on the packaging, primers can help us to make the packaging de-inkable. So even if you have sort of a 2-ink system with sort of much more bonding of the ink in the material, you can make this possible. The primer has the additional advantage of delaminating it, which of course is sort of a nice effect, especially if you think about laminates of the same material. So ultimately, what is possible for PET is a very viable way for flexible packaging as well. And just to show you that in the flex spec space, we're a little bit behind. For paper, again, this has been done for centuries. One of the reasons why you get recycled paper that is white, in many cases, is because they have a de-inking step in their repulping. Of course, it works differently, but the idea is very much the same. Here you also see just one example where we even have sort of a metallization there. It even works there. Here you see it with a primer applied in the structure. Just to give you a bit more feeling for how does a packaging structure that is made for de-inking, here sort of a laminate structure, and the pouch that you had in your hand built. So you have the PE, the adhesive. Here we even have sort of a printed oxygen barrier coating, so we're moving away from EVOH, LOX, COX, so the things that we saw before, to recyclable oxygen barrier coating. Then of course we have sort of our whites and colors. We have the primer and then sort of the laminated MDOP layer. All of this is done in line, so during the normal printing process. So something that, I'm looking at the machine producers also, we know how to do. And us as sort of ink providers, we have the ink and coating solutions there. Now, I also want to be honest, and I want to say de-inking is nowhere at any recycler at the moment for post-consumer waste. So you can travel the entire world. You will not find a single recycler that has a hot washing process for their films for post-consumer waste, so whatever happens in your household. But we see de-inking more and more becoming a reality. And as mentioned, we need to push for that reality because as machine producers, which probably some of you are, I think you probably also have an interest that we still print quite a bit on packaging. So where do we see it? We see it in industry initiatives. I think the most prominent example is Siegwerk with their advanced recycling project that they're looking really to build a recycling facility at scale that has de-inking included. We see it a lot and increasing now at packaging converters. Because packaging converters have the challenge of finding themselves in a spot where the brands ask for recycled content in the packaging. Of course, this is difficult if you're in the food space and you have flexible packaging, and of course, you also want to make sure it's safe. So for converters, deinking is a really nice way of adding recycled content to their packaging from printing waste. And everybody who's ever set up a printing machine knows how much that is. There are two concrete examples here, but you'll find quite a few more from Koveris in the UK and Huhtamaki in Turkey. And now there's a third step, making sure that the packaging is ready to be de-inked. So as mentioned, in many cases, you don't even have to change your packaging, especially if you have sort of a monostructure surface print to begin with. And that is easily testable to see if your pack is already de-inkable. If it's not, you transform it. And the great thing is, right now, packaging structures are in transformation anyways. So if we start redesigning a packaging, let's already think about de-inking built in instead of having two design loops. And this could be thinking about different binder systems, about the material selection, or also, if required, adding a de-inking primer. And what you see here on the slide are a few examples. There are plenty more. So I think if you would talk to any of the ink suppliers out there, they would give you their fair share of examples. And also what you see here, of course, sort of examples for pouches, but also where it's quite prominent is for shrink sleeves, for PET bottles. Because the beauty here is you already have a hot washing process. And wouldn't it be great to actually put more material into an established hot washing recycling process by using a de-inkable shrink sleeve? Just one example. So I want to urge us all of us who have an interest that packaging remains to be printed, to think about de-inking as part of the future solution. And it's very much feasible. At the end of the day, it's not rocket science. It's about implementing. And I think rarely we have solutions that are that straightforward and really only need the implementation. So this was a little bit of a sneak peek into, I don't even want to say the recycling of the future, because it could very much be our present and in many cases is, but about ways of sort of rethinking ink, rethinking de-inking as part of the recycling process. Of course, there are many other things that are driving a circular economy beyond inks, but somehow inks are always connected to it. We're a tiny part of the overall packaging, was like 2 to 3%, I think is what we always say, depending on the pack structure. But the enabling factor that we have for a circular economy, or the hindering factor that we have for a circular economy, is tremendous. So let's look at some of the driving forces, and I'm going to zoom out a little bit of just inks, but I'm going to try to make the connection where possible. So I think it's not to be debated anymore that we need to move to a circular packaging system, a circular material system. I heard you had some conversations about climate change this morning. That is very much very much linked. If you think about sort of the waste crisis that we have. So I'm very happy that we don't need to have the debate today anymore if it's needed or not. We had that 5 years ago, we moved on. Nonetheless, now we have to make it successful. And I want to touch base on a few success factors. And it all starts with the circular design, so what you see at the very top. But then, of course, we want to look at how do we produce and manufacture? How do we consume? And at the end of the day, how do we collect, sort, recycle, and ideally feed back into that loop? So picking up also sort of this idea of the LCA and the life cycle. Let's start with the circular design. So one thing that we urgently need, and that luckily is also emerging more and more, is harmonized design for recycling guidelines. If you're a brand, there's nothing worse than if you design a packaging where you think it's recyclable, you try to do a really good job, and then in one market it's deemed recyclable and the other not, and it's just a huge mess. You need a whole team to just figure this out. I think the USA is actually a good example right now where we see the different states coming up with different regulations, so even within one country, it becomes an intellectual challenge that nobody really needs. Especially because there's a lot of consensus around what makes packaging recyclable. This is sort of where inks and coatings companies come in to give their insights, their knowledge to make it uniform. In Europe, we're seeing a huge push towards harmonization. If you think about the packaging and packaging waste regulation, it's a regulation. It's not translated into national law. This will put 27 countries on one design guideline within the timeline outline, so 2030. But we even see that at a global level. If you think about the Global Plastics Treaty, and even though it seems far removed, negotiations in Nairobi and Ottawa and sort of the UN having these great panels, at the end of the day, something very concrete will come out of it. And what they are going to look at is at design guidelines that are already working in certain markets. So backward, the look to Europe. One of the great things about these design guidelines, and one of the things that we can all agree on, is the move away from multi-materials to monomaterials. And this comes with challenges, as Ewald also outlined, from a functionality perspective. But we're seeing many investing actually in those new lines. So new MDO-PE lines, for example. Especially a lot of our Asian colleagues customers are brave and investing even though there's no real market yet. But with it, of course, also inks and coatings have to contribute their fair share. And we talked a lot about inks and the optics of inks, but there's actually a whole nother level of sort of the functionality of the packaging in terms of printed coatings, but also making sure that the new materials work in the converting process. If you think about the different heat or melting points of the different materials. Again, here, printed solutions are a real part of the solution, no matter if you talk film or paper. One thing that we sometimes don't like to discuss, because it also could mean less business, but it is necessary to think about where can you actually reduce unnecessary packaging. This is always the first step, and I think if you go to any grocery store, you're gonna find examples of that unnecessary packaging, over-packaging. And this is, to be honest, probably the easiest one that we tend to overlook. And as mentioned already, sort of the role of inks and coatings. I want to address the elephant in the room here, or put the fish on the table, or whatever saying they have from where you come, is right now, often if we transform the packaging structures, we actually end up at a higher price point. The MDO-PE might be more expensive. A new innovation in the coating space might be more expensive. Somebody just invested in a machine that needs to be depreciated, and. And we cannot magically make that go away. But what I always want to make sure in the conversation is that we have fair comparisons. If we compare a pack that has been optimized for the past 40 years sometimes with something that has just hit the market, I don't think that's a fair comparison. If you try a recipe for the very first time, will you be perfectly efficient? Will you have zero waste? Probably not. If you travel a new country for the first time, will you get lost? Take a different route than you're supposed to? Yes. All of that is part of bringing innovation into the market, of changing things that have been established for many years. And that comes at a cost. But that doesn't mean that if you walk the way once more, if you think about collaborating with your value chain, that those prices can go down and that we can actually come to a point where design for recycling packaging is also attractive from a financial perspective. Because we've done it in the past, so why should it be impossible to do it again? So, moving to production and manufacturing. So, of course, one of the key levers here, if we think about the production process, and that feeds back to the circular design, is the use of recycled content. And this could be because you purchase material that already has recycled content in it, but it could also be your de-ink material from your own production waste setup that you feed back into your film. Another route that we see to sort of defossilize our packaging and our production manufacturing is the use of bio-based materials. This works in some cases, it doesn't work in all cases, and to be quite honest, often it's the most expensive option that you're gonna get. So I think there are probably some other alternatives out there to look at as well, but part of the solution space. Then of course we have the production. So no matter if you're an ink producer, a printer, a machine producer, you will always have waste in your production. Minimizing that is essential to really have circular packaging because, of course, we want to look at the final product that doesn't become waste but feeds back in, but also we want to look at creating zero waste during the process. And what we picked up here with waste, you can, of course, take further if you look at what kind of energy sources do we use in terms of renewability, of not wasting. So this is something that you can take way beyond sort of just the pure waste aspect. And then, now we're at the money part again, investing in those transitions. This could be machine investments, but it's also time investments. Machine time to run a printing trial for a new innovation, to discuss the results with colleagues, to brainstorm with one of your suppliers or partners or brands. And this is something that we cannot shortcut. We will have to have these investments, no matter if they're in hard cash in terms of machine or sort of our time and our respective ideas. So all of us are also consumers. And what we see here, of course, is an ever-increasing trend that consumers are aware and conscious about the problem of plastic waste and broader environmental issues. This is, I don't know how many different studies have shown that. And interestingly, that's a global phenomenon. Sometimes you would say, well, if you're in an emerging market, this might not be the case. But those communities are often much more linked to the devastating outcomes of climate change, of plastic waste. So there's a huge awareness of the problem. It's just more difficult to act upon it if you're sort of in restricted financial situation. Do not forget about reusable options. If we think about not overpacking on our side as a consumer, thinking about reuse options, let it be because you buy something that is in a reuse system, or think about how can I reuse a container that I have at home for multiple purposes beyond the primary. And then, of course, there's sort of consumer acceptance. And we just picked out one example here, which is in terms of recycled content. So a lot of the material, recycled material that has this grayish, brownish look could be technically used. If you think about sort of secondary packaging, all those different kinds. But the consumer doesn't like gray or brown plastic. They want white, they want transparent plastic. So I challenge all of us to think sort of beyond the color of the plastic and open again the solution space. The same thing here goes into the willingness as a consumer to be part of this transition. So if you ask people, and there are many studies out there, are you willing to pay more for sustainable packaging? 75% on average say, yeah, absolutely, I'm willing to pay more. When the brands start doing the tests on the shelf, it drops to, I would probably say not even statistically relevant amount of consumers that are actually willing to switch. So this is a huge challenge. But again, I would challenge us on two sides. So one, as a consumer. If you buy something that costs, I don't know, 2 euros, whatever that be in your local currency, and there's 1 cent more, so 0.5% more that comes from a more sustainable packaging, are you really going to notice the difference at the end of the day? I would argue in most cases not. Of course, there are different consumer categories, but for everybody else here in the room, I believe we will not notice that. The other thing is challenging us as an industry to really see how can we make it price competitive. It doesn't need to be on par, but it should not be significantly more expensive. And I just want to give you a nice example because I think that's always sort of the proof of point that it's possible. So whoever's German knows Rossmann, so it's a big drugstore chain. And they sell their own brands, so white label brands. And this is both soap, so the same product category. This one is a PE, fully recyclable. This one is a PET, not recyclable, at the same price point for me as a consumer. So it is possible, and to be honest, this one also had the much nicer sealing on top, so the recyclable one and this one, so the recyclable one even looked nicer for me. So again, as a consumer, we carry responsibility, but you cannot offload the responsibility on the consumer as an industry, and this again, I think we as sort of an expanded server of those packaging products come into play. So you can design the best recyclable packaging if it's not collected, then it was all fun and games, but you're not going to have any impact. This can be depressing, especially if you put a lot of work into it, but also think about the design for recycling part, so what we saw in the beginning, being the incentive to actually invest and scale into collection, sorting, and recycling. Because nobody would invest in recycling if there's no packaging that's actually recyclable. So we need both at the same time. Luckily, or maybe not lucky, depending on whatever perspective you take, recycling has tailwinds. So if we think about the resource crisis that we're in, we will need to seriously think about how to capture the raw materials that are already in the cycle to make sure that we don't entirely devastate our planet and with this ourselves. The planet is not going to care, it's going to recover, but we're going to be in trouble. Also, if you think about fluctuating prices of raw material, virgin, we saw the prices of the last 2 years. Often you can build recycling value chains, especially if you put a little bit of thought into it, partnering with the right people, and have price stability. You might even have independence of imports and exports. So there's almost like a risk management component, a price management component to recycling and the use of recycled content that sometimes we almost forget about, especially in the packaging space, but which is very common sense if you look at other materials, especially in the metal space. Because people are inherently lazy yet good-willed, sometimes they need a little bit of a push. And this is where regulation comes in. I mentioned it in the beginning, and at some point, you will not have a choice to recycle or design for recycling or collect. And we're seeing this across the globe. Different extended producer responsibility schemes coming up that really push them. Some are designed better than others, but the trend is very clear. And what's great about this regulatory trend and sort of this idea of maintaining our resources and managing them, it gives an incentive to invest in recycling. I think roughly 3 or 4 weeks ago, the first fund, and I forgot the number, I would have to look it up, just for investments in recycling technologies was launched. This is the first time ever. So there are VC, venture capital people out there who see a business case for recycling and are willing to put the money there. And usually they have great analysts, so I think that might be a safe bet. Of course, when we think about recycling, we sometimes tend to forget that it actually starts much earlier. It usually begins at household level. So the better we are, the better the municipalities are at providing sorting at home opportunities, the easier it is to have cost competitive, high quality recycled material at the end. And the easiest to separate dry from wet. If it's just that, you've already contributed immensely. And also I want to sort of take a step back and say, especially here with all those nice machines, we often think about recycling as being this highly technological thing. You see the big recycling plans and so forth. But roughly 60% of the global waste is actually collected by people, is sorted by people in the informal and semi-formal waste sector. And this shows that there's value in the resource. This shows that we have opportunities to sort and collect and bring this back into the value chain independent of the maturity of our economies. And I think that's an important message. And lastly, I want to add one thing that we didn't talk about yet today, and it fits nicely to this point. Again, for us, people working in companies, working on technological solutions, this is where we focus on. But there are new terms coming in now. We heard about a carbon neutral circular economy, which is great because climate and circular economy is moving together. And now we're hearing more and more a word of a just transition, so a just circular economy. And this is important because the people I just mentioned, so the 60% of waste that is collected by people, we should honor them for the work they do and make sure that it stays a fair process. Those are harsh working conditions, but ultimately they contribute to the recycled content that we have in our markets today. So think about this also when you think about the circular economy. How is it technologically feasible? We heard a lot about inks today. How can I connect it with economic considerations, de-risking of my supply chains? But also, don't forget about the human aspects, the people working, but also the gratification we all get when something goes right, when we made that transition work. So I'm going to wrap it up just very quickly. There's no way going back when it comes to circular economy. The question is, how quickly are we going to move forward? I don't know, nobody knows, but we can all make sure we push a little bit ahead. And just here, I mentioned most of it. You will be pushed if you don't move yourself. Regulations, industry level, but then really also the market and the brands. So with that, we get a piece of confetti. And we have time for Q&A. Yeah, sure, I think there's a microphone. I think there's a microphone so everybody can hear you.
Oh, thanks, Alina. My first question to you, is this primer is a design for current PU-based ink system produced and marketed by Siegwerk India?
So I'm looking at my technical. So for the PU system, I'm not sure.
Yes. No, the ink system available in India, is that ink system is compatible with this de-inking primer?
Yes, I mean, first hand, of course, we haven't tested that because the full PU system is not a commercially running system as of now because there is no market demand as of now. But technically, I don't see why it should not be. So I think it's possible.
So this primer is also available there in India?
The primer is not available. That's a product that's produced in Germany, but we can make it available in India.
Because last 1 year I have been looking for this technology when you last presented in Elite Plus. Dell.
We will make it available for you, Vara.
By the way, there's more than one ink supply.
now the
there are also different primers available worldwide. So if you need primers and if you have questions, I'm happy to give you answers.
So the second question, you have discussed on 2 layers, that MDO, primer, print, adhesive, oxygen barrier coating, and then sealant layer.
Yep.
So if I use a metallized MDO in between, so them same technology, the adhesive from Henkel we have to buy?
No, that's so you can use any adhesive. They were just a collaboration partner in this context. So it's not a specific adhesive. It's really the primer that then makes sure that it delaminates and you can get to the ink.
So what about the effect of metallization in this case for 3-layer laminate?
Yep. So I think you saw it. I had the one where it is also possible with sort of the metallized layer.
In the spec, yes. In the not in the MDO. I am talking about MDO.
There.
Yes.
Okay.
So MDO and then primer, print. In place of oxygen barrier coating, I will put a metallized MDO. So the metallized layer, how metal will be, dissolve there in that de-inking process.
Yep. I mean, in theory, it should work. I think we would have to look at the exact structure, but that's exactly the idea. So, I mean, this is now one setup, but of course you can have other setups as well. We might even want to challenge if you need a metallized layer to begin with.
It depends also on the metallization quality you have.
No, metallization will be a high barrier metallized. You know, this MDO, P, metallized MDO and P is a replacement of a ultra high barrier PET, aluminum foil, poly substitute. So when we are going for D4R structure, so we have to take care of that also.
At the moment, yes. I mean, a lot of people are working on that. I have seen myself trials where it worked, but I'm not sure yet if it works in every case. So if you have no metallization, it would make it a lot easier for your process.
That means a lot of challenges are there.
There are still some challenges ahead.
Devil is always in the detail.
Thank you.
Very much. I have a question about the...
I think if you move it a little closer.
Okay, about the water-based inks and polyolefins. It was a technology that comes to the market about 10 years ago. But what is the situation now in America and Europe and for the inking and the lamination? It works better because it's water-based. What is the challenge for the producing and increasing the market for this kind of inks?
I can tell you that there's a lot of movement also, especially when it comes to replacing nitrocellulose, which I mentioned in length before. There are alternatives today for surface printing with water-based inks. There are alternatives for lamination jobs. There are even alternatives for retortable packaging with water-based inks. And as far as I can tell from our own products and from what I've seen, water-based is a real valid alternative to solvent-based inks when it comes to de-inking, when it comes to flexible packaging, when it comes to recyclability. Also from the studies I've seen when we compare the different binder systems, water-based inks are generally acrylic or water-based polyurethanes. Both of them have pretty good performance in the recyclability tests. So I don't see an issue there.
Yeah, but I think it leads back nicely to when people ask about, so what are trends in the machine space, the drying capacities in the printing space. I mean, this is then something that ultimately also becomes more relevant. Everybody wants to go to the party, right?
Thank you so much. Round of applause for Alina Marm and Ewald Rempel. I do have a question about adoption speed of circular economy globally. Are there regions that are particularly ahead that we should be looking to as an example?
I mean, making predictions is difficult. I think they're very different. So if I look into sort of the Southeast Asian market, Indian market, especially Southeast Asia, I have the feeling we're much faster to bring things to trial and onto the market to test. In Germany, sometimes, I don't know, this feels like a lifetime project, not in all cases. Also on the regulation perspective, sometimes these things, I mean, India was a good example with the straws. Suddenly, it felt like overnight, the straws are banned, where of course, sort of with the European regulatory setup, we have a longer consultation process. So yeah, I don't think there's going to be a winner. I think they will move differently. Let's see how we measure then the speed. You know.
I agree. I mean, and I can also see huge differences depending on the markets. Traditionally, Asian markets, they have a pretty fast decision process when it comes to changing regulations and implementation of new regulations. In Europe, and especially also in high costs, high salary markets, takes longer, it's more complicated, there are more regulations.
Maybe just one more thing to add, because we often talk about European regulation, and I mean sort of Europe wanting to be at the forefront. A lot of that regulation has spillovers into all the other markets. I mean, packaging waste regulation is a good example. If you want to import into the European market, you have to adhere to this. On the reporting side, where you report on your sustainability as a company, it's European, but of course, there will be information asked from global suppliers. So I think at some point it will be difficult to really see who pushed, who pulled, and who moved.
Okay, thank you so much. Thanks also to the German Ink and Coating Association. They will have a couple more sessions next week on Wednesday and Thursday. So do check out the Q program. If you're here next week, we'd love to see you once again. Tomorrow we at the Cube have a break, but there's the German print convention on. If anyone speaks German, then you might like to come and see that. But it costs a ticket. The ticket has a price. So, oh, it doesn't. Okay, I had the information that you had to pay for the ticket. No, okay, so it's also for free, but it's in German. Have a wonderful evening. Thank you so much for your attention, and thank you for this
Thank you for
deep
coming,
dive.
guys.
Thanks.
Thanks.